Okay, good morning and welcome to CIS 2400. I want to thank you for showing up. We're trying as much as we can to make these sessions as productive as they can be. Maybe we are making them productive, maybe we are not. Only history will judge us. But life is the way it is. I hope you're continuing to observe the social distance and wearing masks, washing your hands when you're out there. If you've been watching the news, I know this is more of a cliche, too much repetition, but the numbers are going up higher. So just be careful about that. The other item is, like I mentioned in the email, if you vote or if you help somebody vote and you have a way of justifying that you participated in that civic activity, I'm going to be giving you some extra credit. So make sure you do it. And the other item is the one I'm going to talk about is the progress, where we are. So if you go to the course documents, you will be able to access the syllabus, and the document opens like that. And this document is the last page of the syllabus, kind of gives you a breakdown of what we've been doing and where we are now. So we're actually in week 9. We're going to be covering chapter 7 on networks and mobile businesses. And then next week, we'll look at enterprise applications. And then we'll finish by chapter 9, system development and project management. So technically, we have 2 more weeks minus this for planning, and then we have our exam. So if you look at the calendar, I hope it can pop up here. Yeah, very beautiful. So we are here today. We have another session next week on Wednesday, and then on the 4th, that will be our last online session. And when we move to November, so this will be our last session, we probably will have the exam around this week over here. So the exam, if you have something planned, we can arrange. You either take the exam earlier or you take the exam a little bit late. But by this end of this week, we should be done with our classes, hopefully. So that's where we are. So plan ahead. Now, what you realize is as we get closer to the end of the semester, the number of assignments will start decreasing, and your chances of improving your grade, if you have not been doing very well, but also be decreasing. So what I'll ask you to do is make sure that you're paying close attention more to the assignments that we are required to do. The assignment from last week, for the most part, most of you did very well, and I was very impressed. But I was also a little bit disappointed because I think we went through the assignment and we had a video, and yet some of the students were sending me their answers in Microsoft Excel, and one person even actually sent it in a PDF file. So that is a little bit disappointing. And the fact that we're taking all this time to through the assignments and give examples, and then you're not even getting the time to watch the video is a little bit disheartening. But at the end of the day, life goes on. And what is very important is for you to know why you're going to school. People go to school for all different kinds of reasons. So if you have people who are not even getting the time to watch the videos and do the assignment, at least the bare minimum, that is a little bit disheartening, and also it communicates another message. So basically what I was looking for is for you to create all these tables here, and most of you, I think I had like maybe 10 students or so who did very well. And then you're going to populate the tables, and what I was looking for is to make sure you have the tables, and then I'll go back and look, make sure that you have the relationships, and we explained all this, the relationship. So this is what you're calling relational database. This is at the heart of management information system. Because if you don't have a way of collecting the data and storing the data and sharing the data, then you cannot use information system. So I was looking to make sure that you have that, and then you can go ahead and generate queries, or what you're calling the reports. So the reports will be coming out of the data, and basically that's what you do when you access your GPA. You want to see what is your current GPA. What you do is you go to Banner, you put in your information, your student ID, and maybe, yeah, student ID, I think that's good enough. And then you hit a button, and then what will happen is actually the system will generate for you all your classes and the grades that you got, and it calculates the GPA per semester and then overall GPA. That is a query, that is a report that you're getting. and that is coming from a database. So there is a database back there which contains the information about all the students and all the class that you have taken and all the grades that you got for that class. And that database is populated by data from all the different professors when you take a class with them. So that's how that relationship is enabled. That's why you're able to take a class in criminal justice, you take a class in the School of Business, you take a class in education, and then all that you can be able to see it in your report. It's because of that relationship, because any department has your information. They have your student ID or your social, and they have tables that have all that information. So that is enabled through that. So when you are working with the tables, when you create the table, most of you are entering the data in this format. So we have what we call the design view and the datasheet view. So the design view is kind of like the one that you look at, like you open the hood of the car and you're looking at the different components, how they are working. And then you as a driver, you get in the front seat and then you can drive off the car. You don't have to worry about what is happening in the engine. So this is the design view, and this is where we were setting up our field names and the data, and we talked about some other components down here. For the ones who are the CSB majors, you'll go into details about this. So once you create this, most of the time, you're not actually going to be entering the data through this view. You won't be entering the data through here. We have what you call the forms. So once you finish with the table, you can create a form that you can actually use to enter the data. And this is how the form looks like. So this is what you call a form in Microsoft Access. And with this form, it allows you to enter the data, and it's much, much easier because you can see they're asking for the ID, you enter the information there. And then you can use the key on your computer to move on, enter the data, and then you can navigate down here all the way. When you get to the end, you can actually add another item. So you see it gives you a blank, and then you can go ahead and populate it like that. So these are the forms. This is what you call the form. And for all of this, we are not doing this for this assignment, but this is how the system is supposed to be set up. So you have the forms. Anytime that you go on the internet and you're probably buying something and they ask you to provide your shipping information, you're going to be presented with a form, usually something that looks like this, and you have to enter your information, and it has the field names labeled and on like that. So basically what you're doing is when you enter that information and then you hit the submit button, that information is going to be taken to a table that has been set up for that company, Amazon or whatever, for the payment. So usually what you'll have is you have the tables, and then you have the forms, and then you have queries, and on like that. So for the CSB majors, this is, excuse me, a concept that you'll come back to in the future. So I just wanted to bring that to your attention. You're always using these resources, and at least now I'm hoping that you can be able to relate and see how those resources are generated in the use of management information system. So that was part of that assignment. So the other component that I was going to mention about is on, excuse me, on the voice thread. So we have a voice thread for this week, and this is the assignment. So we're going to be working on what is streaming data. The information about what is streaming data and how companies use that is found on page 281. From page 281, actually specifically page 282 of your book has information on what is streaming data. Maybe you'll be able to cover that before the end of the class. So that's where you'll get the answers for this. You're going to be giving me 3 specific reasons, all 3 examples of, of companies, and give me clear explanations of how they are using streaming data. Okay, so you're familiar with Netflix. I think Disney is doing it. Very many companies are doing that now. So you can give me an example of how they're using streaming data. And we'll be talking about this in reference to networks and mobile business. So usually what you're supposed to do is with the voice thread, you'll come in here and you click on this button, and then it brings you to this page right here. You click on this link here, and then you can see all the information about all your colleagues down here. Now, for you to get credit, I need to see your name up here. Okay, so basically what you're supposed to do is you'll come here and then you read the question. Then, like I mentioned before, you click on this and you click on the video, make a recording of yourself, and then you come back later and then at least watch a couple of your colleagues' videos, and then go ahead and come back and click on the same button, and then you go ahead and you can comment. Now, most of you are watching the videos and commenting without making your post, and that's not going to earn you points. So you need to create a post and then watch your colleagues and then go ahead and comment. And when you're commenting, I've seen some people say, I totally agree with what you're saying, and you say it in a very nice way. That's not adding to the discussion. At least make sure that your contribution is substantive. So that is what I expect from you in terms of the discussion and of the voice thread. Now, please don't wait until Sunday to do your posting, because what is happening is some people are making their post before Thursday or Friday, and then some you have to wait until Sunday when everybody else comes in, and then that's caused a lot of confusion. I've been a little bit more flexible, but moving forward now, posts have to be done at least by latest Friday. So at least make sure you post by Friday so that your colleagues can go back and watch your post and get time for them to comment on your post. Because if everybody is making their post on Sunday afternoon or Sunday evening, it becomes very complicated and is beating the sense of what we're trying to do here. So make sure at least you do that. Okay, so that is that. That's the part of the assignments. Now, the other part is on the multiple choice questions. I think most of you are doing that. We have not had a lot of problems. So any questions so far? Okay, so let's look at what we're going to be working on today. Learning module. So I'm going to post this information on Blackboard as usual. And the good book says that a shepherd had 100 sheep and one of it was stray. I'm not saying that you're stray, but he left the other 99 and went looking for the one. So maybe that's what you're doing here. Everybody else is sleeping or having a good time, and then we are here, so life goes on. Okay, let's do our part so that when we sleep, at least we'll be comfortable sleeping knowing that we did what we were supposed to do. Okay, so week 7 is on the network, and you've been using this concept in terms of the network. So the learning outcomes are saying that we should be looking at the benefits of wireless networks. You already have a mobile device, so that's an example of that. At home, you probably have wireless internet access. So we have all the benefits of that. And then you're going to be discussing the different networks categories. Now, if you're a CSB major, this is something you should know. If you're not a CSB major, you should have an idea about this concept, because hopefully you'll be a manager or you're going to be working in a company and they have these resources, and at least it's good for you to have a wider knowledge of these components. You're going to be looking at some of the challenges of wireless network, and usually one of the challenge is how to secure the wireless network. I'm sure when you are at home and you're trying to connect your wireless internet, you always see your neighbor's wireless access, and you can see their Wi-Fi. So you want to make sure that that's actually a security risk. So we're going to be looking at how you can minimize that. We look at the enterprise. Anytime that you see the word enterprise, you're talking about the whole organization. So for the NCU, we can talk of the enterprise is looking at all the different networks that are on campus. You can think of Cisco, they have that. You can think of Amazon, they have that. And then 3 primary business applications of wireless technology. We'll be able to see how businesses use wireless technology. So those are kind of like the main things that you should be familiar with before we finish this class. Okay, so let's dig in. And thinking this is going to take us to the page, and we can go through the notes. So I'm going to use the book. I'm not going to use the PowerPoint slides. It's the same concept, but the book at least goes into more details, and I can kind of like point to the areas that you need to be looking at. Okay, so the first part looks 3 components, and we are going to be talking about networks. So network, we are familiar with social networking. Network is where you have a system that is made up of different components. Networks. We talk about wireless networks. So we're talking about a computer network where we have different computers connected together, but the way the connection is, we are not using cables, we are not using wires, we are using radio frequencies to help us to communicate. So that's what you call wireless networks. Now, before we can get that, we need to have an idea about the different types of networks that we can have. So we have this concept of local area network. Like I said, information system uses a lot of language that you're already familiar with. Something local is something around here, something in the vicinity. So local area network, we talk of it as connecting of computers in close proximity. Okay, so you have office building, or even school, or even at home. So some of you might have network at home, and you might have one printer, and you have 2, 3, 4 people at home, and they only use that one printer to do that. That's an example of a network. And in that case, if you're not using wires to connect the printer, you're using wireless. So local area network, at least have an idea about what you mean by a local area network. Is a group of computers which are in close proximity. When you go to the library and you're working on an assignment and you need to print, that's an example of a local area network. You don't need to be directly connected to the printer to be able to print. We have another type of network that's called the wide area network. So this spans a large geographical area. Okay, so you have something like the states, you have the province, or you have the country. At home, you can actually access the resources from the state. Okay, so if you have like the DMVA, you can go to the DMV, Department of Motor Vehicle, in the different locations, and all those different locations are connected to a central location which has all the data for everybody in the state. So that's an example of what you're calling a wide area network. Okay, so they go ahead and explain a little bit about that. So at least have an idea what's local area network, what's a wide area network. And then there is this other concept of what you're calling attenuation. Represent the loss of network signal strength measured in decibels and occurs because the transmission gradually dissipates. So basically what you're saying is you have two people who are maybe 10 feet apart, and one person is talking to the other person, in that without raising their voice. So they'll be able to hear each other very clearly. If the other person moves further away and the first person is still talking to him or her without raising their voice, what will happen is as that person moves further away, he or she is not going to be able to hear the first person very clearly. Because what is happening is the voice signal is not able to travel that far. So that concept whereby you're not able to hear somebody very clearly as you move away from them is what you're calling attenuation. And remember, we said with wireless network, the signals are actually traveling in the air through what you're calling radio signals. So as two devices move far away from each other, we're going to be having what is called attenuation. Okay. Now, to minimize that, we have what you're calling a repeater. Just like the word says, what you can do is those two people, if they're 100 feet or 100 yards from each other, if you want them to be able to communicate, what you can do is you can actually put somebody else in between them at the 50 yard. And what will happen is the first person will tell the person in the middle what they want to be communicated, and the person in the middle will tell the other person what they want to be communicated. So in that case, that person in the middle is the representing what you call a repeater. So that repeater is going to receive the signal and then repeats the signal to reduce attenuation and extend its range. Okay, so that's how we are able to communicate and use what you're calling the wide area networks. So very similar concept. Sometimes when you see those radio signals, they help in communicating in that sense. We have another concept of what's called the metropolitan area network. Now you have to understand the concept of metropolitan. You can see if you're good in English, it becomes very easy for you to understand information system because we know of what is a metropolitan. Okay, so that concept is you apply to what you're calling metropolitan area network, and this is called MAN. So we have local area network is called LAN, wide area network is called WAN, and then metropolitan area network is what it's called MAN or MAN. Okay. Now we also have internet-enabled mobile devices, and we talk about what you call in the mobile business or M-business or M-commerce. Okay, is the ability to purchase goods and services through wireless internet-enabled device. Most of you are already doing this. So the advantage that you have is that you're growing in the information age and you have access to all these resources. So probably most of you don't even buy things on your computer anymore. Okay, you have apps that are allowing you to be able to do that. So these are some things that you can do with your mobile devices. Okay, so a little bit here about the invention of these resources and how we go back to wireless telegraph and on like that. You can read that for your own discussion. So wireless networks, we measure network performance in terms of what you're calling the bandwidth. So you might have had this concept in radio communication, talking about the bandwidth. It's nothing else but it's the maximum amount of data that can pass from one point to another in a unit of time. So the way you can think of bandwidth is like the lanes on the highway. If you have a road that has more lanes, you can accommodate more cars. If you have a lane that a highway that is only made up of one lane, you have fewer cars. So that's called bandwidth. So another concept that at least you should be familiar with, if you're a CSB major, you need to know this deep, is how we measure bandwidth. Okay, so we are saying a bit. You have to understand what a bit is. It's short for binary digit, BIT, binary digit. So you have BI, and then you have the T, make bit, binary digit. Now this is different from what you call the decimal system. Now we are familiar with the decimal system. How many values or numbers are in the decimal system? Anybody? Decimal system. Are you familiar with the decimal system or the decimal numbering system? Anybody? Should I cold call? Taylor? Hector? Here? You guys even here? Anyhow, decimal system is the one that we use every day. It has 10 digits, 0 to 9. That's what you call decimal. Okay? Dec, December, 12, decade. Okay? So we talk about, actually that's wrong. December doesn't mean represent 12. Dec is 10. So we have decimal. My bad. Okay, so we have the decimal system which has 10 values, 0 to 9. Binary, we talk about bicycle, binoculars. Common theme there is what? Is bi, which means 2. So binary digit. We're saying is the smallest element of data and has value either 0 or 1. This is also how we represent electricity, because we talk about computers as an electronic device. Electronic, it means that it needs electricity for it to function. So for us to represent that, digital, we represent it using zeros and ones. So that's the binary digit. So we have the bit rate or the data rate, the number of bits transferred or received per unit of time. So we have kilo. Kilo represent 1,000. Kilo, 1,000. So bit is the same as 1,000 bits a second. So you'll see this being represented by kps. So remember, this is b is lowercase for bits a second. So that's how we can represent the speed, okay, the bandwidth. Now, the modem that we used to use many years ago was only 56 kilobits per second. That thing that used to make some noise when you're connected. Mega comes from the word million. Okay, somebody got the mega ball. You're going to win a million. So mega represents million, and we use m bit to represent that. So it's 1,000 kilobits per second. So 1,000 times 1,000 is a million. Now, Ethernet is, if you're a CSB major, you need to know what that is. Is the connection that uses, you see those blue cables that you see at home? That's an example of what you're calling the Ethernet. So it was 10 megabits per second, but now we have moved to almost 1,000 megabits per second. Then we have what's calling the gigabit, okay, or GB. 1 gigabit is 1,000 megabits per second. Anytime that you are trying to get internet access, some of the ISPs like Spectrum and Verizon and T-Mobile, not T-Mobile, AT&T, they will give you some speeds and they tell you, we provide you with 1 gigabit speed or 300 megabits per second or 400,000 megabits per second and things like that. So that's how they're telling you that your speed of download, how fast things are coming to you, and how fast things leave your computer when you're communicating is going to be like that. So streaming, like Netflix, has been enabled by the increase in the bandwidth, because now we have computers that can process the data very fast, and we have communication channels that can do that. So if you are a CSB major, you need to be familiar with this. If you're not a CSB major, at least have an idea about what is a bit and on like that. So basically what you're saying is that for a computer to communicate, a computer does not understand this language. Okay? So a wired network uses like this information here, computer does not understand. So although this information needs to be transmitted from my computer to your computer, it does not understand this. So what usually happens in communication is the computer picks every letter, see like this one here, and converts this into zeros and ones. And usually what the computer will do is every letter gets to be converted to 8 bits. So 8 zeros and ones, a combination of 8 zeros and 1. That's what it's called byte, B-Y-T-E. So this is going to be converted into 8 bits. This space is going to be converted into 8 bits, this into 8 bits, and on like that. And then that information is going to be transmitted through the communication channels. And then when it gets to the other side, the computer will process that and change the bits into a format that we can understand. So as human beings, we can understand these alphabets. Okay, we can understand this language here, but the computers don't. So the way the computers communicate is in forms of zeros and ones. That's what we call the digital. So we say the computers are digital devices because they communicate using zeros and ones. So at least make sure you understand that. We're familiar with Wi-Fi, okay? So it's a means of which portable devices can connect wirelessly to a local area network using an access point. That is what you use at home. That device that allows you to be able to connect the internet is what you're calling an access point. And most of the access points actually have what you call the routing. So a router is nothing else but is a device that allows your computer to be able to know where the traffic is going to be sent. So on your computer, you type CNN.com, that router will take that information and send you to the CNN server, and then you're able to get those files. You type nccu.edu, that router gets that information, sends it to the computer server at Central, and you're able to get access to Blackboard and on like that. So that's the concept of what you're calling an access point, which usually sometimes has router integrated in it. So look at that. We have different technologies. So we're talking about the protocol. Protocol is nothing else but is a set of rules of how the devices communicate. So usually human beings, the protocol is when you meet somebody for the first time and you're going to introduce yourself. People in the old days used to shake hands. Now we are not doing that because of COVID. But we used to shake hands, and then you say, "Hey, how are you doing? My name is XYZ." And the other person will say, "Hey, how are you doing? My name is ABC," and on like that. That's what you call the set of rules of how people engage. Computers also have protocols. They have rules that they have to follow. So that's what you're calling the protocol. So for the Wi-Fi communication, they have these different protocols. And these protocols designate the frequency. Remember I said they're using the radio waves. So for those devices to be able to communicate, they need to be at a certain range. Okay? So that's what you call the frequency. So 802.1118. So usually this is based on, if you're a CSB major, you learn a little bit more about how we end up with these numbers here, but this is based on a committee. So there is a committee of experts that meets, and they come up with the rules of how devices are going to be communicating. So if you're a CSB major, you'll come back to this a little bit more details. But this committee meets and then they agree. It's like now we have the debate coming up tomorrow, and we have the presidential debate committee. So they met and they agreed you're going to change some rules. So they're going to be doing some muting of the mic and on like that. It's the same concept here. So they set the rule, they set the protocol of how that communication is going to be done. Excuse me. So the frequency and the maximum speed. If you are CSB major, you need to be familiar with these, because if down the road you want to take, like for instance, mass exam or network exam, they ask you about the relation between this. So you need to know what is 802.11a and know the frequency, and then know the maximum speed. So this speed you may never sometimes achieve this speed. And that's the same thing that happens. If, for instance, Spectrum tells you you're going to be getting 300 megabits per second on your internet, you may never get that because there are very many other factors that go into that. It's the same thing. You go to a dealership and you buy a car and you look at your speedometer, the car says that you can do 170 miles an hour. Very few people will ever do that. And very few cars will actually do 170 miles an hour. Okay? Because there are very many factors. One of them is what? There are no roads that are going to be conducive for that. And then, of course, there are traffic rules. So all those things, the same thing that applies with the maximum speed that you're going to be achieving. So 5G is actually now where we are moving into. Okay, you might have heard about that concept. And is nothing else but is a concept that means that you'll be able to have more things that you can do on your phone. So if you have seen the progression of the phone, the beginning, the type of phones that we had were only able to make calls. And then we had phones that could make calls and then send text messages. So we had 1G and then 2G, and then we moved to 3G. You could make calls, send text messages, and even do some videos. Okay? Now we have phones that we can actually even be able to buy stuff through. So we can do mobile commerce. So we are advancing that. And as we move the 5G, which is the fifth generation, we're saying is a wireless broadband. So the word broad. Okay? Somebody has broad what? Like for instance, broad shoulders means that he has big shoulders. Broadway. Okay, they do a lot of shows in there. Okay, so broadband technology means that you can accommodate more data, more information on the system. Okay, it's based on the 802.11 AC standard. You see the 802.11 1 AC is right here. So that's 5 gigahertz, and then it has 6 gigabits per second. You can see that's a lot of capacity. You can do a lot of things here. So you can actually have a network where you can play video games, you can do streaming at high speed, and do other things like that. That type of network will be able to support this kind of resources. So that's where we are heading towards that. So at least be familiar with that. So wireless network benefits, remember I said you're going to be looking at that. So we look at something like cost, eliminating of wiring expenses. So when you go to the computer lab, you see a lot of wires from one computer to another one. With wireless, you don't have that. And probably you have seen that. With wireless, you can go to Starbucks, sit down, and you do your work. You don't need to connect to their network. Okay, and then you can move around from one table to the other one with your devices. Customer service, we are looking at the diagnostic with access to greater amounts of more timely data. You can avoid manufacturing issues before they even happen. And then, of course, the most important one is what? Mobility, ability to move around. Real-time data, you can get that very, very quick. Remote work, okay? You can work remotely because you have access to internet resources, okay? Now, there is a concept that you need to be familiar with. We talk about the local area network, wide area network, metropolitan area network, and there is another type of network called the PAN, or personal area network. So that is like the one that you form when you are using Bluetooth. If you have your Bluetooth and you're able to communicate with your Bluetooth, that's what you're calling a personal area network. If you have something like Alexa's or any other of those devices that you're using for a smart home, that also will help you to have calling a personal area network. Okay. And then, so with all those, then we have the biggest network of them all is what is called the internet. So the internet is capital I, because you can actually have an internet within an organization. Because internet is nothing else but is a network that is made of different components that are connected and sharing resources. So sharing resources means that you're sharing things like printer, you're sharing things like the routers, and you're sharing files and all that. So internet with a capital I is the global network. So the global network that is connected all over the world and allows us to be able to share the resources. So have a clear distinction between those different types of network. Internet with a lowercase I is a local network. So a company can have something like that, but with the capital I is the global one. Okay, so this is actually about that: personal area network, wireless local area network, wireless metropolitan area network, and then wireless wide area network. This one has not been very, very popular, okay, because of the cost and also because of lobbyists and things like that. Because basically what we're supposed to do was to come and allow metropolitan areas to have wireless access. Okay, so that's why if voting is very, very important, because you determine who is going to be making the rules and laws for you. So that gives you a little bit of that. We know from something about the Bluetooth and the distance that it can communicate, and on like that. Any questions? Okay, so you probably have been familiar with hotspots, but basically what you're saying is designated locations where Wi-Fi access points are publicly available. Okay, so sometimes they tell you if you have AT&T phone company, you'll be able to access hotspot all over. So that's where that concept is. So this is an example of what you're calling a Wi-Fi wireless fidelity network. You have an access point, which also acts as a router. And then that access point allows you to be able to connect different devices. That's what usually we have at home. And then you have a broadband modem, okay? And then you have the internet. So most of the companies will give you an access point and they give you the modem, which has the router also. Some companies have everything integrated together. Spectrum, I think they charge you like maybe $5 a month for your broadband modem, but you can go to the store and get one for you. So modem actually stands for two words: moderator, demodulator. Moderator, demodulator. Okay? And basically what we're talking about is the communication that is taking part around here is what you're calling digital, the zeros and ones. But for that information to pass through the communication channels, the telecommunication channels, like the telephone lines, the cables, that's how the information goes out. It has to be changed from digital to analog. Okay, so we have the digital signals, which is like that. And then we have the analog. So let me see, digital signal graph, digital signal graph. See, so this is a digital signal. So if it is up here, it can represent 1. When we are down here, we represent that by 0, and then 1, and then 0. Okay. So for the signal to transfer over the internet, we need to change this into what you are calling analog, or what you call a sine curve. Okay, analog signal. So this is analog signal, sine curve. You might have heard about that. So the computers communicate using zeros and ones, and you can see the voltage because that's electricity. That's how electricity transfers. And then for the communication to take place through the communication channels, it has to be changed into analog signal. So that is why we need what we are calling, where were we? The modem. Okay, so modulator, demodulator. And then when we get the internet, the communications, then the reverse takes place. So this is your home, and then you go back to the internet, and then information comes back to you. It has to be changed from analog into digital. So it does that reverse. It's kind of like you have somebody who is doing interpretation. Okay, so you have two people, somebody in the middle. One speaks Spanish, the other one speaks English, but they can understand each other. So they need somebody in the middle. So somebody will speak in Spanish, the interpreter will get the message and then tell the guy in English. The guy in English will ask a question, the guy in the middle get it, transmit it into Spanish and ask the guy, and on like that. So the interpreter is what you're calling the modem. That's what he's doing, changing the signals from analog to digital. Okay. Got too many meetings today. Okay, so spot sensors, these are things that we have seen being put into devices. Okay, so they do that in tennis, golf, hockey, baseball, all the way like that. So that's something you should be familiar with. Talk about WiMAX here. We're going to all the details. So ISP, Internet Service Provider, you need to be familiar with that. So internet service provider, this person who allows you to be able to access the internet. So technically, who owns the internet? Anybody? Who owns the internet?
The service providers?
Say that again.
The service providers?
The service provider, like an example?
Like Spectrum or Comcast?
Okay, so spectrum, everybody agree or anybody has a different answer? Okay, so technically nobody owns the internet. There's nobody who owns the internet because remember what we said, internet is nothing else but is interconnection of computers and internet resources all over the world. So Spectrum is an example of what you're calling an internet service provider. So they provide the infrastructure to allow you to be able to access the internet. Okay, but they don't own the internet because internet, what do we do when you go on the internet? We access information. Okay, so like now what you're doing is we are in this class and you're able to see the course textbook. This is not owned by Spectrum. This is not owned by AT&T. But from your home, maybe you're using Spectrum, maybe you're using AT&T to access this. This is an example of what you're calling internet resources. So the internet service provider, they are these big telecommunication companies, and what they do is they provide the infrastructure. It's like providing the roads for us to travel. Okay, so we have the cars, we can get on the highway, and we can use the highway to help us to move from one location to the other one. Okay, so nobody owns the internet. And that's the one of the reason why the internet is so widespread and everybody can have access to it. So this shows you an example of an internet service provider, and then they have the WiMAX tower. So you might have seen this kind of towers around, and they allow you to be able to access the internet. Sometimes you might have seen a satellite. So satellite help with what you're calling with communicating with what you're calling line of sight. So the devices need to be able to see each other. So the signal is going to be able to travel. They travel straight, and then they need to be able to have a device that receives them, and then they're able to be transmitted to your home. Sometimes we don't have that, and still they communicate if there's no barriers in between them. So that's an example of that. Now we are familiar with the cell phone. Now we call them mobile devices, but they're actually cell phone. And the concept is actually based on what you're calling the cell. So a cell is nothing else, but is actually made up of. So if you talk about the concept of a cell phone, so we have these different cells. We can talk of this as one cell, another cell, another cell, another cell, another cell, and each cell has what you're calling a tower. Okay, so usually what happens is that you're able to move around, and as you move around, your phone communicates with this tower, and then this tower will be the one that's going to be bringing the messages to your phone. And then if you want to talk to somebody else who is maybe in this location here, when they send their message, that message will come to this tower, then this tower will pass that message to this tower, and then this tower, and then it gets to you like that. So there is actually a mathematical computation that happens when you are calling somebody, and what will happen is the nearest tower will get that message and then find out the person calling, and then do a mathematical computation to find out what is the shortest route to get that message to them. So if you are CSB major, maybe a little bit of that. If you're computer science, you'll actually be able to do that and go into details about how that computation is done. It happens so fast, we don't even realize that is happening, but that is something that happens all the time. And then what happens is that as you travel with your car, as you move away from this tower here and come closer to another tower, your phone is actually going to do another computation, and the tower, they work together and they determine which tower is going to be picking you up. That's what is called the handover. So your cell phone is going to be handed over to another tower, and then you keep moving on from one cell to the other one. So that's how we got that concept of the cell phone. So in the earlier days when the cell phone came back out, we actually calling them the cell phone. But now because of the mobility, how we are able to move with them, people moved away from the cell phone to what you're calling mobile devices. Because now any mobile device is any device that you can use and you're able to move with it. Your computer is a mobile device. If you have a laptop, that's a mobile device. So that is how the cell phone technology works. Now, if you watch CSI and some of those crime scenes, they're actually able to track somebody, and they say somebody committed a crime somewhere, and they're trying to say they were not in that location, but they can actually use your phone to tell where you are, because all what they do is they go to that location and then they look at the tower, and they'll be able to determine how many phones were connected to that tower between that period, and then they're able to see if your phone is part of that. So I'm not telling you how to commit the crime, but if you turn off your phone, there's no way it's going to be able to communicate with the tower. So that's how you can actually keep tab of somebody. When somebody puts a locating device on somebody's vehicle or a phone or whatever, they're able to do that because of these towers here. And the same thing with a satellite. So if you're using the satellite is up there, that's how you're able to use a GPS and on like that. So that's the concept of the cell phone and how they work with that. You're familiar with the smartphones that's enabled by 4G and 3G and on like that. Any questions? Okay, we should be done in the next maybe 10 minutes. And before that, I talked about the concept of streaming, and that's where the voice thread for this week is coming from. And you're saying streaming is nothing else but is a method of sending audio and video files over the internet in such a way that the user can view the file while it is being transferred. So Netflix is known for that. It's all streaming. Okay. So that's the concept of what you're calling stream. Because in the old days, what you'll usually do is you'll download a file, and then the file will download, and then once it's downloaded is when you're able to view that file. But now we don't need to do that. You can actually view that. Now, the advantage of streaming is you don't actually need a lot of storage space on your computer, because basically what you're doing is it's like you're watching you watch a movie, and that movie is running from the provider's location. So that's the main difference between streaming and downloading. With downloading, you need to have the storage capacity on your device. With streaming, you don't need to do that. So we have seen that happening a lot. And then some of the examples of what you can do. Another concept that you should be familiar with is what you call the voice over IP. Now, IP is nothing else but is the internet protocol, and it's nothing else but is a set of rules of how computers communicate on the internet protocol. So voice over IP, basically what you're saying is instead of using the regular telecommunication channels to communicate, you're actually using the phone, the internet, communicate. And that is actually much cheaper because you're using the already established communication channels, and also sometimes the signal is much more clearer. So that's something you should be familiar with, voice over IP. That's what Cisco is very well known for that. Most of the phones at Central, they're using voice over IP. Okay? So, and other components out there are also using that. So streaming data is generated continuously by thousands of data sources, which typically send in the data records simultaneously and in small sizes. So this is where you're going to be getting your responses for the streaming question on the internet. And before we finish, I have to talk about the net neutrality. Now, remember I said nobody owns the internet. So there is this concept of what you call net neutrality. And basically what we mean is that since nobody owns the internet, nobody should be able to control the internet. Okay? So net neutrality, actually there's a debate that has been going on for some time. And basically what we talk about is ensuring that everyone has equal access to the internet. Net neutrality. Now, it is the founding principle that all consumers should be able to use the internet and be free to access its resources without any form of discrimination. So what you can think of, and you can read a little bit of this, is we have what you call the ISP, the Internet Service Providers, companies like the Comcast, the Spectrum, the AT&T of this world. So what they do is they provide the infrastructure. Like now, Google is laying the cable for what they are calling the Gigabit Ethernet or something like that. So they have the 1G, they're laying the cable. So basically what they're doing is they're going to be providing the infrastructure. Now, Netflix, if you're familiar with Netflix does not own any cables. Netflix is not an ISP. CNN is not an ISP. Fox is not an ISP. But Disney is not an ISP. But you are able to access their resources on the internet. So this concept of net neutrality, what we're trying to say was companies like Comcast and AT&T and ISP should be able to dictate who uses their infrastructure to access the internet. And what we're trying to do was to actually make sure that companies like Netflix, they pay a little bit more, because Netflix is making a lot of money through the streaming, but they're not contributing directly to the infrastructure. because what usually you do is you have Spectrum and you're paying ISP to access Netflix. Okay, so with net neutrality, they actually went to Congress and they were trying to have a law passed to make sure that people don't have what we are calling like equal access to the internet. So somebody can actually control that. So the court passed that, but hopefully we hope it's not gonna stick. So the U.S. Court of Appeals for the U.S. for the District of Columbia struck now. This Court of Appeals, they have judges. These judges are appointed by a person in office. So President Donald Trump, he has appointed a lot of these judges. Okay, and one way, depending on what you think, some of these judges might not think like you. They may think like you, they might not think about you. Remember, elections have consequences. So with net neutrality, these judges struck down the Federal Communications Commission net neutrality rules, which would have required internet service providers to treat all web traffic equally. Okay, so the ruling will allow ISP to charge companies at Netflix and Amazon fees for faster content delivery. So this might just look like it's only going to affect these big companies, but down the road, we don't know what they can do. Because what usually they'll do is they'll tell you that if you are, for instance, on Netflix, if Netflix is not paying them well and you want to stream Netflix, they might slow down the speed of Netflix. Then you can watch your movies. Okay? If you want to go to some internet website, you might not be able to do that because those websites are not paying a service provider. So there is actually some negative aspect of it, but because of the lobbyists, many people don't even know this was happening, but there is a lot of repercussions for it down the road. So read a little bit about it. It is the concept of net neutrality, which might actually change internet as we know it. Because remember, with the way the internet is, it is the same all over the world. Of course, some countries do some censorship. If you go to China and maybe you're trying to access things like the Tiananmen Square, they don't allow you to do that. So they do some censorship, but that's a little bit different from what you're calling the net neutrality. In a democracy, you should be able to access anything that you want on the internet. That's the double-edged sword of the internet. Okay, so satellite, you can read a little bit about that. So those allow us to communicate and connecting the wireless network. So we can finish with this. So usually when you go to the internet and you want to buy something, you'll see a padlock or a key that tells you that this website is safe. So let's say if we go to Amazon, for instance, and you're trying to buy something, so that's Amazon. What should we be buying? Oh, actually, it's right there. You see that key right there? So you see that padlock there? So that is telling me that this page, this is Amazon. See what happens? I type something and then I was redirected. So this sometimes happens a lot actually. And some of the websites you have to be very careful because that's a way that they usually make people buy things that they don't want or even get your data. Okay, so Amazon is what I wanted. Okay, so that's Amazon. So that's the key. That padlock there tells me that this is secure. This website is secure. Okay, and the way they do that is by using what's called a socket secure layer. So socket secure layer, okay, secure sockets layer, SSL, is a standard security technology for establishing an encrypted link. So basically what we mean by encryption is when you type, like for instance, you type your credit card information on the internet, and that on a form on the internet, like when you're buying stuff, that information does not travel like that on the internet. So it's going to be encrypted. So if you have a 1, that 1 is going to be changed to something like X. And then if you have a 5, that can be changed to something like a Y. So encryption usually takes place in this form. So let's do this a little bit faster. Maybe you might not be able to get another chance to do it. So let's say you have a name, a word, or whatever you want. So hope. So that's the word that you want to communicate on the internet. And basically with encryption, what you do is you can start with like A, B, C, D, E, F, G, H, and then you have the letters 1, 2, 3, 4, 5, 6. So with substitution type of encryption, this actually is not going to help. A, B, C, D, E, F, G, H. IJKLMNOP, like that. And then you have 1, 2, 3, 4, 5, 6. You have 7, 8, 9, 10, and on like that. So basically, what you call substitution is you have the word hope, but you don't want to communicate this word on the internet, because what can happen is if somebody, there's actually a device that you can use to tap into communication channels and you can get somebody's message. Like when you are at home and you're communicating using the Wi-Fi, that message is actually flying all over the air. If somebody has a device, they can sit outside your home and they're actually able to see all the communications that are traveling through there. So to minimize that problem, what usually you do is you do what's called the encryption. Now, with encryption is whereby you're trying to change the message that you're communicating. So what you do is you come in here and you have like A is going to be represented by 1, and then B by 2, and then C by 3, and then D by 4, all the way like that. Such that instead of sending the message hope, then what you'll do is you'll come and find out what H represents here, and let's say H represents 9, and you have 9, and then O, let's say O represented by maybe 13, you have 13, and then P is represented by maybe 7, you have 7 there, and then E is represented by 4, you have 4 there. Okay, so this is the message that you're going to be sending across the internet instead of the word hope. So somebody who is listening, they see that and they don't understand what is happening. Okay, now if they know that you're using this type of substitution, do your encryption, they can reverse this and get the message. So what usually will happen is this message, when it gets the other side of the internet, they're going to have another device that's going to change that message and you're able to get the message originally. So that's what we're calling encryption. And you can install that on the devices to make sure that your messages are traveling safely. So that's the concept of the socket, secure socket layer, and also what we're calling the HTTPS or SHTTPS. So sometimes you'll also see that on the website. They either have that key there or they have the secure. So let's see, what is that? Message, do they have, it's interesting, anything that has HTTPS? Let's see, HTTP. Anyhow, so you get the concept. So HTTPS, I don't want to keep typing and moving back and forth. So hypertext, hypertext transfer protocol, that HTTP is the set of rules that devices use to communicate on the internet. Okay, so nowadays, most of the computers know when you want to go to a website, you have to just type the name of that website and they take you there. But originally, the way the website was set up is you had to start with the HTTP, and then you put /:, and then you put the website. You have what you call the URL, the Uniform Resource Locator. So anytime that you see S, it means that that website is also secure. So we have the HTTPS, which is Hypertext Transfer Protocol. That is how we are able to see this information right over here on the devices, is because of that. So at least read a little bit about this. The word driving is a concept that is out there, whereby you have people driving around and they have devices that will be able to tell you what is the access points for your devices and what's the password and things like that. Wall chalking is actually where people drive around and they put marks on the road to tell people that this is where we have a Wi-Fi access point, which is not secure. So you can use it to access the internet. It used to be very popular in the old days, is now not that popular. So that's what we're talking about. So we are going to stop here. And any questions?
No questions.
Okay, so I'll put this on the blackboard and then I'll have another session and I'll try to cover as much as possible. So at least make sure you read about that. And if you want to revisit this WEP and WPA, that's good. If you are not a CSB major, you don't have to really worry much about this. But if you're a CSB major, you need to know about IRS preference, privacy, and Wi-Fi protected access. These are the things that you actually have on your access point at home, and is what you use to protect it. So they tell you about the password and then the access point, and you have to change it. That's because of this. So it allows you to have a more secure access point. So that's enough for today. I'm going to stop this recording.